Hey math kids, today we're going to talk about quadratic inequalities, and here I'll just show you a few examples. So you may or may not remember, but inequality is when we use like a greater than or equal to sign, or a less than or equal to sign, or just less than, any of that stuff. Now, if we have something that's in this form, we know that that is going to cross the x-axis 2 times. And if we were to draw a sign diagram, it would look something like this. So if that's -2 and that's 1, this would be positive, negative, positive. Because this piece is above the x-axis, this piece is also above the x-axis, and that's why it gets positives. But then everything in between -2 and 1 is below the x-axis, and so that's why it is a negative. Now, if we have something that looks like this, whoops, not like that, something like this is getting a little too slanted. All right, let me try that again. Okay, if we have something like this, then the entire thing is above the x-axis, and so everything is positive. So the sign diagram will just be always positive. And then the last scenario is where we just kind of touch the x-axis. So let's say we have that. Let's say that's at -1. Then the sign diagram is going to look like this. Negative, negative at -1. And then just that one spot, we know that it just touches right there. So in general, when a linear factor has an odd power, there is a change of the sign about 0. And when a linear factor has an even power, there is no sign change about that 0. Okay. So let's just do a couple examples, and I think you'll catch on. Okay, so we're given this, and we're asked to draw a sign diagram. So this crosses at 5, this crosses at -3. And so if we draw the sign diagram for this, we mark the x-intercepts. And in between -3 and 5, we're above the x-axis, and the other places we are below. This piece is below, this is piece below, so those are negatives. Okay, now if we have something that looks like this, and it kisses the graph at -1, the graph is, almost always above the x-axis. It just touches the x-axis at that one point. And so positive, positive on the sign diagram. Okay? Now we have x squared plus 2x minus 3, and we're asked to draw a sign diagram. So we need to know the x-intercepts, so I'm going to factor it. So we get that. So x minus 1, x plus 3, and so the roots that come from that, -3, +1. Now since we know it's a parabola, and specifically we know it's like this, and we know that it crosses the x-axis, we actually could right away write the sign diagram like that. Now, if you feel like that's too conceptual, then what you can do is you can pick any values that are in any of these areas. So you can pick -4, 0 would be a good one here, and then 2. And we can just plug these in and see what type of sign we get. So if we plug in a -4, -1, -4 plus 3, this gives us a negative number. This gives us a negative. Negative times negative is positive, and we see that that's positive. Now if I plug in the 0, I get 0 minus 1, 0 plus 3. So that's a negative answer. That's a positive. Negative times positive is negative. And then if I plug in the 2, 2 minus 1, 2 plus 3. So that's positive, positive. Positive times positive is positive. So if you want to do it conceptually, it's a little bit faster. But if the conceptual side of it kind of confuses you, then you can always fall back on just doing a little bit of arithmetic. Okay, here's a new problem. Now, this one, it's going to have just a root. It's going to have a repeated root at 3. That's what this tells us. And so we're going to have this sign diagram. And since it's upside down, we know that it's going to be minus, minus. And just touch right at 3. Now, once again, you may or may not feel comfortable with that. So to find that 3, we could have set this equal to 0. Okay, we divide by -4, divide by -4. So that's 0 equals x minus 3 squared. Square root, plus or minus 0 is still 0. Add 3, and so x equals 3. So that still found this. Now, you may or may not feel comfortable with marking these as negative, so we just want to pick something to the left. 0 is to the left, 4 is to the right. And if we plug those into the original and see what the sign would be, that can help us out. So we plug in a 0 right here. 0 minus 3, quantity squared, -4. So that's -3. -3 squared is +9. +9 times negative would give us a negative. Now if we plug in a 4, we get -4. 4 minus 3 squared. That's 1. 1 squared. 1 times -4 would be a negative answer. And so we end up with the same sign diagram. So once again, doing it conceptually is faster, but it's also potentially confusing. And so just do whatever makes sense to you. Okay, now we need to solve for x, and we're given an inequality. Okay, so since it's quadratic, you're almost always going to get everything onto one side when we have a quadratic. Okay, and then this one we can factor using box method. So we have 3, -2, that gives us a -6. 1, 6, 2, 3. And we want it to add up to 5. So we actually have 2 ways of doing that. So we could add these if they're both positive, or we could subtract these if one's negative and one's positive. Now we choose the top one because that's the only one that multiplies back to a -6. 2 times 3 would give us a +6, so that is the incorrect answer. Okay. Now we plug it into our box. And then we get -x, and we get +6x. Okay. Now we can take out a 3x. We can take out a -1. We can take out an x. And we can take out a 2. So multiply these back just to double check. So 3x times x, 3x squared. That times that, positive. That times that, -x. That times that. Okay, so that works. So we end up with 3x minus 1 and x plus 2 is greater than or equal to 0. Okay. Now, if we solve each of these for the roots, we do 3x minus 1 is greater than or equal to 0. Well, we just want the roots. So let's just say equals 0, then x plus 2 equals 0. And so add 1, 3x equals 1, and so x equals 1/3 minus 2, x equals -2. Okay, so if we're doing a sign diagram, we get -2, we get 1/3. Okay. Now, to test this is going to be a positive parabola. So it's like this. So it crosses. And so this is going to be negative. This is going to be positive. This is going to be positive. So that's what our sign diagram looks like. So if we want to know when it's greater than 0, we just look at where these positives are. And so when x is less than or equal to -2, we're positive. But we're also positive when x is greater than or equal to 1/3. Now we use the greater than or equal to because, or the less than or equal to, whichever one, because that's what we had up here. If this started with just a greater than, then we would drop the lines underneath both of those. Okay, let's try another one. Okay, so we have x squared plus 9 is less than 6x. Okay, once again, we want to move everything onto one side because it's quadratic. Like I said, you will almost always do that. There's a couple cases where you don't have to do that. But, okay, this one we can factor just using regular t factoring. And so if we make both those negative, we can get x minus 3, or we could just write it as x minus 3 quantity squared. And then we're still less than 0. Okay, so our root occurs at 3. And since our original is a positive, we know it's going to be a parabola like this that just kisses the x-axis. And so we know that it is positive and positive. And we're looking at this inequality, and it is never less than 0. And so we just can write a sentence like the inequality is never true for real values of x. Because since it's less than, we would need to see some negative signs for that to be true on the sign diagram. Okay, we have one more example that has 3 parts. So we're given this. Okay, and then we want to know the different values of x for where it cuts the x-axis twice, touches the x-axis, and misses the x-axis. And so what we're going to do is just pull out our a, b, and c, and then end up using our discriminant. So the discriminant, once again, is b squared minus 4ac. And our a is right there, our b is right there, and that's our c. Okay, so I'm just going to plug this in first. So k plus 3 squared minus 4 times k times negative 1. All right, if I do k plus 3 times k plus 3, then if I multiply all that out, it's 4k. All right, distribute k squared plus 3k plus 3k plus 9 plus 4k. Combine like terms. I get k squared. Let's see, what is that? So 10. And then plus 9. Then we can factor that. And so we get k plus 1, k plus 9. Okay, and then we can create a sign diagram. So that gives us negative 9 and negative 1. And if we just look at this one, because that's what our sign diagram is for, that's going to be a positive parabola. So positive, negative, positive. Okay, feel free to go through the little bit longer one if the conceptual thing doesn't work for you. Okay, so the first question that it asks, and we're just going to answer it from this sign diagram, it says cuts the x-axis twice. So we want to know the situation where it does this, and there's two values right here. And so we're going to do that based on these positive values. And so when k is less than negative 9 or k is greater than negative 1, then that's true. Okay. Now the next situation, we want to know where it just touches. So like this situation like this. So that's just going to be right at these 2 points. And so we're going to say k is equal to negative 9 and negative 1. So when it's equal to either of those. Okay, and then to know where it doesn't touch the graph at all, so like this situation, it's just going to be wherever it's negative, because once again we want the discriminant to be negative for that situation. And that's just going to be in between 9 and negative 1. So negative 9 is less than k, is less than negative 1. Okay, if you need additional help, come to Math Lab. Until then, calculator.